Hello and welcome to episode 2 of our lecture 2 on global change. So in episode 2, we're going to talk about this emerging framework called Planetary Boundaries. Episode 2 will present this emerging paradigm, and then we will finish lecture 2 with a traditional interview discussing concepts that we covered in episode 1 and episode 2. In episode 2, you will learn an Earth system biophysical approach to help humanity deal with climate change and other global environmental threats. So this is very, very important in two aspects. First is an emerging approach. So it's something new at the front of science. And secondly is a promising approach that can help us to cope with all the threats, environmental threats that we discussed in episode 1. The structure of episode 2, we start with a brief mention to the human occupation and domination of planet Earth. Then we move to planetary boundaries. We define and try to characterize what they are, and then conclude this episode with a brief mention of the potential of the planetary boundaries approach to help us cope with, as I said, some of the environmental threats. In the last 200 years, humanity, 200 years since the beginning of the Industrial Revolution in around 1800. In the last 200 years, therefore, humanity has transitioned into a new geological era, which has been termed the Anthropocene. The Anthropocene is an era that has been defined by accelerating departure from the stable environmental conditions of the past 12,000 years. This period of stability was known or termed by geologists as the Holocene, which was an era that saw human civilization to arise, develop, and thrive. Human enterprise has since then expanded rapidly beginning with the Industrial Revolution, and has threatened such a stability that was observed as so necessary for human development during the Holocene era. The environment, as we discussed in episode 1, has been changing rapidly from the stable Holocene state to an unknown future state of significant different conditions. Humanity needs to change course, but in what direction? And what principles should guide the journey? One way to address this challenge is to determine safe boundaries based on fundamental biophysical characteristics of the planet and operate within them. To meet the challenge of maintaining the Holocene stable state, a group of 28 internationally renowned scientists proposed a framework which they called Planetary Boundaries. Planetary boundaries refer to safe biophysical boundaries which, if crossed, could generate unacceptable environmental change for humanity. Boundaries define, therefore, the safe operating space for humanity with respect to the Earth system. 9 planetary boundaries were identified: climate change, biodiversity loss, nitrogen and phosphorus production, stratospheric ozone depletion, ocean acidification, global freshwater consumption, land use change for agriculture, atmospheric or air pollution, and chemical pollution. Before we move next and discuss briefly those boundaries, it's important to note that the crossing of one boundary may seriously threaten the ability to stay within safe intervals of the safe levels of the others. And this is because we live in this complex system, the Earth planetary system, in which all these boundaries are interrelated, interconnected in ways that we don't understand well. Therefore, if we violate one of the boundaries, we can generate some type of reaction in cascade that can alter the condition of the others. This figure here shows you these 9 boundaries. And it's important to note here, first of all, the scale of the processes that they describe. 2 of the boundaries, the climate change and ocean acidification, are systemic processes operating at planetary scale. The other 7 are slow processes without known global scale thresholds, and they actually are aggregates from local regional scale. So accumulation of impacts at a local and regional level are aggregated and generate global scale impacts. This graph here shows you a little bit how the boundaries were defined and some important concepts associated with the definition of the boundaries. If you look at the graph on the left, we have a representation of a boundary for which there is a clear threshold. A threshold, as you may know, is a tipping point. Is a point if transpassed, if we pass that point, the system shifts dramatically to a qualitatively different state, most of the time unpredictable, no reasons to know. For example, of transgressing or trespassing a threshold is what happened in one of the areas that I spent some time studying, the same area, the southwest of the United States. So by the 1800s, we have a rich rangeland. However, in the following years, the rangeland was submitted to overgrazing, intensive grazing, a huge number of animals grazing on the land. So that caused some stress on the land, and coupled with a prolonged period of drought that still reduced the resilience of the system. And a threshold was passed, and the land shifted from a rich rangeland into a shrubland or desert. So very difficult, if not impossible, to use any technological means to transform that shrub desert in the southwest of the United States into the previous rangeland. So anyway, I want to discuss briefly here this figure and to show you how this threshold is related to 2 of the planetary boundaries, which I mentioned, the climate change and ocean acidification. So the blue line represents the safe operating system. So the graph on the left is as an example for you to understand the notion of threshold and the presence of threshold in some of the boundaries and no threshold in other boundaries. The graph on the left has on the horizontal a control variable, a variable that is being manipulated, and on the y-axis we have the response variable. To illustrate this example, I have as the control variable the CO2 concentration, ppm. And a response variable to change in CO2 is, for example, the extent of land ice. As you know, as the CO2 concentration increases in the atmosphere, we have the global warming, and we start losing the portion of land covered by ice. So, therefore, the blue area here represents the safe operating space. So, the planetary boundary for climate change would have a limit, a boundary, which should not be transgressed. The green area represents an area of uncertainty. And somewhere within that area or zone of uncertainty, there is a threshold that we don't know exactly what it is. But once we pass that threshold, as you can see, there is a dramatic decline in the extent of land use. So little increases in CO2, once you have passed that threshold, will result in large losses of land ice, of land covered by ice. The location of the threshold is unknown. And one of the reasons, and probably we will never be able to find out exactly what it is, because first of all, thresholds are not fixed. Thresholds are mobile. So as the system loses resilience, that threshold moves close and close to the boundary of a possible shift. The other process that you see on the right-hand side represent the other 7 planetary boundaries for which we don't have a threshold, but we still can define the blue area as a dangerous level in which the variable, the response variable will slowly decline. And with that decline would be a corresponding loss of resilience that can result in great impacts and shifts in the environment. In our example here, we have, for example, the control variable would be land use change. And by land use change, I mean the percentage of terrestrial ecosystems under cropland. So as we convert, for example, forest to cropland, the percentage of land use change, which is represented in the horizontal line here, would increase. And the response variable here would be the terrestrial carbon sequestration, which is the process of capture and long-term storage of CO2 from the atmosphere. So as you can see, we still have, the scientists still think that there is this planetary boundary, there is this safe operating space, which is represented here on the right by the green area, and then again, we have this blue area, which represents the dangerous level. And this dangerous level is a period in which you're going to have a sensible decline in the response variable associated with the change in the control variable. And finally, I want to show you here the work that came out of the Planetary Boundaries research. On this table here, we have all the 9 planetary boundaries listed. And I want to go to one by one with you to give an idea of what was attempted and why the planetary boundary concept has the potential to develop global policies that can help us to cope with global environmental degradation. Let's start, for example, with the planetary boundary, climate change. Okay, there you see climate change, the first one there. So the climate change here is measured in terms of atmospheric carbon dioxide concentration. So in other words, the control variable is CO2. It is important to note in this table the last 3 columns. The scientists came out with what they call the pre-industrial value, what that control variable was supposed to be in pre-industrial time, which was before the Industrial Revolution. And then the column in the middle represent the current status, where we are at the present time. And the other column on the left represent the proposed boundary. The proposed boundary is a boundary that was determined by discussion and a little bit arbitrary, but was defined in terms of how much risk humanity wants to take. Let's look at CO2 according to this table. So the value for CO2 in pre-industrial era was about 280 ppm in the atmosphere. The scientists propose a limit, remember, as a boundary at that green area beyond which things can become uncertain and risks increases. They propose a boundary of 350 parts per million. Our current status, this is when this paper was published, and this was in 2009, was 387. So we continue to increase, so we already transgressed, we already passed the proposed boundary for climate change. The next one is the rate of biodiversity extinction. So we refer to this in the first episode of Lecture 2 as one of the 4 spikes of the 20th century. So change in extinction rate, which in this study was measured in terms of number of species per million species per year. So the number of species extinct per million species per year in pre-industrial era was pretty low, was estimated to be between 0.1 and 1. The proposed boundary is about 10, a safe boundary for humanity. However, the extinction rate at current time has been exceeded by 100 to 1,000 times the proposed boundary. The third boundary is the nitrogen production, which goes close with the phosphorus production, and this is mostly associated with increases in agriculture. So in pre-industrial area, the value of amount of nitrogen removed from the atmosphere, or nitrogen fixed, was about 0. The proposed boundary for that is about 35 million of tons per year. Our current status is already 121. So the orange, the three first planetary boundaries here, which are represented in orange, clearly indicate that we have already exceeded the proposed boundary for 3 of the processes, of the Earth system processes. And the consequences that this can have on the other system processes are unknown. Next, we move to stratospheric ozone depletion, or the ozone layer. So this is the stratospheric ozone depletion is measured in terms of Dobson units. The pre-industrial value was about 290, and in the proposed boundary for ozone layer is about 276. So the value, current status, is about 283. The next is ocean acidification, which is related to a carbonate mineral, which is called aragonite in the water, in the oceans. So the presence of aragonite avoids the acidification of ocean water. So it had about 3.44 aragonite in the surface water was the measured in pre-industrial values. And the proposed limit for that was 2.75, and we are already reaching 2.90. Global freshwater use, so they estimated in cubic kilometers per year, and the pre-industrial value was about 415 cubic kilometers per year of global freshwater use. And the proposed boundary for that is about 4,000. And we are just approaching it now at about 2,600 cubic kilometers per year. The change in land use, which represent the percentage of global land that is converted to agriculture or cropland. In pre-industrial era, the percent of agriculture, of land, of global land covered by cropland was very low. The proposed value for that is about 15, and we have already reached 11.7%, so it's rising. In the last two planetary boundaries, the atmospheric pollution and the chemical pollution in the natural environment, they still don't have the boundaries defined for that. It's still a work in progress. It's a work as something to be determined. As we saw in the discussion of the table that I just presented to you, there are 3 boundaries: climate change, biodiversity loss, and phosphorus nitrogen production have already been transgressed. Transgressing the climate change boundary can lead to, for example, melting of ice sheets, rising sea levels, which would be a huge problem for coastal areas in the world as well as for islands. People may lose their country, their culture, and try to move to other areas. So there will be, with rising sea levels, there will be other social and economic problems such as migration. Abrupt shifts in forest and agricultural lands, and increasing intensity in frequency of extreme events such as floods, wildfires, and heat waves, which we already have seen the three of them happening with greater intensity and frequency, for example, in the United States. The second boundary that has already been transgressed is rate of biodiversity loss, which has been skyrocketed, as we saw in the episode 1 of this lecture, in the post-industrial level. As I said before, about 100 to 1,000 times more than what could be considered natural extinction rate. According to a paper by Stephen et al. 2011, which I recommend you to read, and is part of the reference for this lecture, 30% of wildlife will come under the threat of extinction this century, the 21st century. Excessive phosphorus and nitrogen is the third boundary, which has already been exceeded. They are byproducts, by large, they are byproducts of agriculture, and they pollute waterways and coastal areas and adds harmful gases to the atmosphere. Even if the science of planetary boundaries is preliminary, the planetary boundaries concept is a credible attempt to quantify the limitations of human existence on planet Earth. The boundaries delineate a safe operating space for humans' development and well-being. Although they are described in terms of individual quantities and separate processes, as I mentioned previously, they are tightly coupled, they are tightly interconnected, and means the transgression of one boundary can cause a reaction in cascade. If one boundary is transgressed, cascade impacts can put other boundaries under risk and under serious risk, in other words. The proposed numerical values that I referred to when we discussed that table, however, should not be seen as target. So there are what they called, as you can recall, the proposed values for every boundary. If the proposed numerical values are seen as targets, they would risk the possibility that boundaries would be used to justify prolonged environmental degradation to the point of no return. I'll give you a practical example for you to understand what I'm talking about when I say that they should not be seen as target. Think about a speed limit on highways. So you should never see a speed limit as something that you can go all the way too close to it and still drive at high speed. That would still increase the risk of your life and the life of others driving on the highway. So actually they are reference points that most safely you should stay below it. Therefore, setting limits that are well within the bounds, within the green areas that we saw in the figure I showed a moment ago, or as it's referred to as safe operating space, might be the wisest things to do. In conclusion, planetary boundaries approach raises important questions and opportunities for governance and institutions. Although some Earth system processes, such as climate change and ocean acidification, as we discussed, are global in scale, 9 of them become global only when they are aggregate from much smaller local or regional scales. Therefore, efforts to reduce pollution and limit the reverse ecosystem degradation at local and regional scales become important because of their large scale implications. And here is where I want to call your attention for the relevance of the approach we are proposing in this series of lectures, an approach which we call civic ecology. Because civic ecology is essentially directed towards operating into small scales. And in a period, in an age in which, as we have been describing in this lecture, global processes are threatening the stability of the planet. So why should we focus on the small scale community-based processes? Because again, among the 9 boundaries delineated by this group of scientists, 7 of them actually are aggregates that result from the impacts originated in local and regional scale. And that is the scale that seems to be feasible as an alternative to live with and cope with the uncertainties and threats of global environmental change. The paper by Stephen et al. Also mentioned that there will also be a need for an institution or institutions operating with authority at the global level to ensure that the planetary boundaries are respected. So what it means is we can agree and think of using the framework of planetary boundaries to generate policies, global policies, that would help us to cope with global threats. However, even if we do so, if we develop those policies, we still need an institution that operates at a global level to make sure that those policies will be implemented. To continue your study of episode 2, I would like you to answer these 3 questions. First, describe the concept of planetary boundaries and the implications for governance. How you think that this Earth-based biophysical framework can, for example, help government to develop policies to cope with global change. Secondly, what kind of institutional change you think is needed to establish and enforce these boundaries? As we already mentioned, there is the developers of this planetary boundary framework assume that we're going to have some type of institution operating at the global level to make sure that we implement the policies derived based on this framework. But we agree with this concept, how the idea that the power to make decisions stay in the hands of an institution operating at the global level. Thirdly, I would like to ask why remaining within, this is an important question, it's something that I didn't mention in the lecture, but I would like you to think about, why remaining within the planetary boundaries is necessary. There is no doubt about that. However, is not sufficient. Is not a sufficient condition for the bright future for humanity. So what I mean is by coming to a conclusion of the necessity of maintaining our operations within planetary boundaries, in itself won't guarantee that humanity will have a bright future. So there is, in other words, this is a necessary but not sufficient condition. Why? Here I have a list of references that I suggest you to read. Some of them were mentioned in the lecture, others won't, but they are all important. And I strongly recommend, if you have a chance, that you read them. The first one is the work by Ed Ayers. As I mentioned, he came out with the notion of the 4 spikes, and this was published in the 2000 in a book, well-known book called God's Last Offer, Negotiating for a Sustainable Future. The other book is, which is a close associate with the one at the bottom, is a book by Dyer, published in 2011 in a reprinted edition, about climate wars. This is something that was not discussed in this lecture, but it's also plausible impact of the global degradation. The fight for survival as the world overheats, so highly recommended. Of course, there is the work by Stephen and others, including Robert Constanza, which is a famous American ecological economist, how defining planetary boundaries can transform our approach to growth. I use most of this paper to develop the lecture for today. And there is a classic, a little bit dated, published in 1997 in the prestigious science magazine, Human Domination of Earth's Ecosystem. So some numbers have been probably dated. The situation has worsened since then. However, Vitosek and his fellows, his colleagues, give a very good picture of the extent of human domination on planet Earth. And lastly, there is a book that has been published recently by two of the authors involved in the development of the planetary boundaries. And this is kind of an expansion on the concept in which things like the social impacts of planetary boundaries, which were not discussed neither in the original paper proposed in the framework, nor in this class today, in this lecture today. And then they later on wrote this paper, which is very interesting reading, Bankrupting Nature, Denying Our Planetary Boundaries. And that's it for today. Thank you very much for attending this lecture. And I hope to see you again next during our interview. Goodbye.